All right, welcome to Module 2, where more micro lectures incoming. We are going to go over arithmetic operators in this specific module. So when I speak about arithmetic operators, I'm sure you are starting to cringe thinking that we're going to speak about math. And the answer is yes, we absolutely are. The only difference between the math that you probably detest and the math that I'm going to talk about is we only need to build the equations and the algorithms. We don't need to compute them. That's the whole point of the computer. So let's jump right into it. Yeah. So operators, what are they? What do they do? Well, our arithmetic operators are our normal mathematic expressions that we use on a daily basis if we're mathematicians or if we just go to the grocery store and attempt to do a little math. This can start with addition and then work its way through subtraction, multiplication, division, and remainder of. In computer science, or at least within the realm of languages, remainder of is also called modulus. You're going to hear me say modulus going forward. I will not be saying remainder of anymore. Please understand that remainder of is exactly what you think it is. It's the third grade way of doing division, which is, instead of continuing to try to divide the number until you get to a whole value, what you essentially do is whatever is left, that's what the remainder of is. There's also binary operators where we use two values and the operands determine whether it's a true or false, or truthy or falsy. So what is operator precedence? Remember, we're speaking about math, but this corresponds to any equation you write, because there will be situations where you write equations that may not be mathematical on its face, but operates order of precedence mathematically. Now, what do I mean by that? Well, I'm sure you guys, if you've gone through enough elementary school in America, I'm sure most of you have learned about PEMDAS, or please excuse my dear Aunt Sally. Now, if you don't remember this, I envy you, because this is something that is an ever-present part of my memory of elementary school, where we were looking to remember the order of operations for any mathematical expression if there were operators, if there was a mixed operator equation or algorithm. What do I mean by that? Well, let's say you had a mathematical equation that contained exponents, or it contained parentheses or whatnot. All of those things need to be calculated in a specific order to get to a answer or solution that is uniform across the board. So what is, please excuse my dear Aunt Sally? Well, you can look here at the bottom of order of precedence, and basically it sums it up to parentheses, exponents, multiplication, division, addition, and subtraction in that order, with multiplication and division and addition and subtraction really not having an order. So if you wanted to do division before multiplication, that's totally fine. And if you wanted to do subtraction before addition, that's also totally fine. Because when we compute algorithms or equations, especially mathematical ones, we compute them from left to right. Now, what is interesting is we do the same thing in computer science, and this is why we write our variables first. As a matter of fact, we write our data types of the variable first. It's kind of like speaking Latin or French or Spanish, where you have to announce the noun before you can describe it or attribute a verb to it. For instance, in English, I would say, I drive the red car. The red car is out of place. I'm describing something that doesn't exist yet in language, which if you speak Spanish, you can't say it like that. You would literally say the car red, or the car of color red, or, if we were speaking Spanish, el carro rojo, things like that. You have to say the actual object, the noun first, and then describe what it is. The same thing is true for computer science languages, C#, Java, and the like. We have to create the variable or declare it first before we can initialize it with a value. And that's important because without the noun or the variable or the memory allocation or the space or whatever you want that specific thing to be, without it being created, we cannot do anything with it. This is why order of precedence is so important, because order of precedence takes this into consideration as well. And all expressions are evaluated from left to right, just like we do with programming syntax. Okay, so now that we have a very high level of what arithmetic operators are, and hopefully we don't have to go into a mathematics course to describe what that actually means or does, what I want to do is I want to jump into operator shortcuts. So our arithmetic operator shortcuts are a shorthand way of writing our mathematical expressions without having to write them, with a lot of extra verbiage, a lot of extra grammatical syntax, a lot of extra words. So for instance, you can see down here, the variable bank bow plus equals bank bow. Now, what does that actually mean? Well, plus equals means, and if I wrote this out long form, it would be bank bow equals bank bow plus bank bow times interest rate. Basically, what you're saying is I want to add bank bow to whatever is in that equation on the right. And this can be done with subtraction, multiplication, division, and modulus as well. We also, and this is something you're going to see prolifically when we write our for loops, you will see increments and decrements. Now, what's an increment? An increment basically means add 1 to this integer value or double value or whatever that data type numerically is. It can be floating point or it can be integral. Now, what's important about this is you can do what's called a prefix increment operator or a postfix increment operator. A prefix increment operator increments the value of that specific variable and or thing by 1 before anything else happens. A postfix increment operator does the complete opposite. It will not increment your iterator counter value in your variable by 1 until everything else is finished. And normally this is within the context of a loop. So now that we've spoken about, increment operators, I can't help but speak about decrement operators, which is basically the inverse or the reciprocal to your increment operator. Instead of adding 1, it subtracts 1. A unary operator is somewhat the same as well, and it uses only 1 value. All right, so now that we've talked a little about that, let's jump right into the code, shall we? So here we are. This is the old code we've been using. And what I really want to do is I want to use the order of precedence in our equations. So in the last module, in the last micro lecture, what we actually did was we wanted to add 2 numbers, and we were giving an example of how to manipulate and format strings through string interpolation using console.writeline and or string.format. In this case, what I want to do is I want to create an equation that's a little complicated. So this is what I'm going to do. I am actually going to enter a third number for z. And instead of doing this, what I'm going to do is I'm going to create a new variable, and this variable will be called output, or total, I should say. And the total of these numbers is going to be x plus y times z. Now I'm making this equation up as I go along. I want you to see what actually happens here. And then I'm going to say print total. I don't care about that anymore. And let's save. So now what do you think is going to happen? Well, I would say have an opportunity to take a pause and see if you can figure this out for yourself. Write this into your own interactive development environment and see what you come up with. Pause the video if you need to. All right, so if you've actually done the equation, what you will find is that the parentheses or anything within the parentheses is going to execute first. And then the exponents, multiplication, division, addition, and subtraction. So in this scenario, our answer should be 8, I believe, or 7.5, something along those lines. I don't really know. I'm doing the math in my head, and I'm probably doing it incorrectly. I think it's 7.5. Give this a little time to actually power up. I did not refresh it. I probably should have. There you go. So 1 plus 5 plus 1, or 1 plus 1 plus 5 does not equal 7.5. What I should have done is I should have fixed this equation. So I'm going to do that right now. So it displays the right information. 2, and then this is going to be 3, and then we're going to say z, and then total. And we're going to run it again. And this time the string will print the correct algorithm. Obviously, it gave me the right answer. 7.5 was the total. The problem is that the string was formatted incorrectly. And so the algorithm looked off. Now, while this is booting up so you can see the outcome, what I will tell you is the only other thing I believe makes sense to explain to you is modulus. So what specifically is modulus, right? Well, modulus is basically remainder of. How do we calculate remainder of? Quite simple. What we would say is we'll do another double. We'll call this AA, and we'll say 6. Modulus is literally 3 modulus 6, or 3 remainder 6, or 3 divided by 6, and whatever the remainder of that is going to give us an answer. Now, if I did 3 divided by 6, my remainder of is more than likely not going to exist, or 6 divided by 3. If I did 6 divided by 3, I wouldn't have a remainder of. If I did 7 divided by 3, I would. So let's do 7 instead. And this time I'm just gonna type the equation directly into my console.writeLine. And this time I'm not gonna really worry about this one. We're gonna once again cancel that out with a comment. And then I'm just gonna dump it directly in here with no string interpolation at all. So we're gonna say AA modulus. There it is, modulus Z. Now, if I'm not wrong, and quite often I normally do get these expressions incorrect, but if I'm not wrong, the remainder of should be 1. And that's what should return from this modulus right here. Yes, this equation in the total is going to process as well, but it won't display on the console because I'm not right-lining it or writing it. And there you go. Answer is 1. Now, you might be asking, when in the hell would I ever use modulus? Well, I'm here to tell you that I thought the same thing when I was gifted this knowledge, and then realized quite quickly that if I ever wanted to determine what an even number was, I could use modulus. Because if I divide a number by 2 using modulus, anytime that does not return 0, it is not an even number. I can also use modulus to count the weeks of the year, which is very odd because 7 is not a fun number to multiply by, add by, or do anything with. I like 7. I think 7 is a great number to multiply by, but a lot of folks are not fans of 7, just like they're really not fans of, like, you know, I don't know, 7's pretty gnarly. 7, 6, those ones kind of stick out like a sore thumb, you know? But either way, with that being said, that's modulus, and I think that's really where I'm feeling I should stop. Well, actually, no. Let's go over one more thing. Let's go over, for all intents and purposes, let's go over shortcuts. All right. So this is incorrect because it doesn't exist yet. So I tried to use a shortcut on a variable that I was initializing, but you can't do that because what you're essentially saying is the memory location that is at needs to give me the value that I want to add to it. But because we haven't initialized or declared the variable yet, you can't use that shortcut. So if I wanted to use a shortcut, I could do ++, and this is one of those increments. This should return 8 because 7 is already saved in AA. And so if I said AA++, that should increment my value by 1. The same is true. There it is. The same is true if I said minus. And it's going to throw errors because I'm not using X, Y, and Z, and that's totally fine. I guess I could, so it would be quiet, but I'm not concerned about it at all, actually. There it is, 7 again. And then we can say AA plus equals AA. And what's that going to do? Well, it's going to take the value, it's going to add AA to AA and assign that back to the variable AA. I'm reusing the variable all over again. And there you go, 14. And that's it. So I want to stop there and say it's been fun. And every time I teach you guys or do a micro lecture, it really brings me a lot of joy because I relearn these things myself. So as I say in all my videos, good luck, have fun, ciao.